Yeah, except for the fact now it's not functioning.
Just click on the screen once. Sometimes it'll.
Yep.
There you go. Oh.
All right. Nice. At least we got part of the painful part of it out of there. So,
well, the notes are still showing, but I think we'll just carry on this.
Okay. We'll just go with it. I'm not exactly sure why it's doing this to me, but I guess I'll figure it out. You'd think this is the first time I've ever done this. Anyway, so thank you, Chris. I appreciate it. Thanks for everybody being here and going through all this. I'm definitely happy that I got to be here because a little bit of humor, besides the fact that I'm having technical difficulties, is the fact that yesterday I got the wild hair. If any of you have ever seen me, is that I usually have a goatee, and I got a wild hair yesterday that when I woke up in the morning, I was going to shave my face completely clean. Made me sleep outside last night, so I was very happy that I was actually able to make it here without her bludgeoning me to death. So the reason why we're here is to talk about concrete moisture testing and the what, why, and how of concrete moisture testing, understanding some of the different options that you have out there. One of the things that Chris alluded to was that when you look at it, there's approximately a $19 million per week price tag on flooring failures. Yes, you are correct that it is something where there could be people that would debate that being much higher. Now, part of that can be, related to inadequate moisture testing, wrong moisture testing done incorrectly. But at the end of the day, in some way, shape, or form, that is the tag that we're looking at for some level of failure due to moisture testing.
Jason, have you any idea if that number was the same back in the day when we were using cutback bitumen type adhesives?
What I can tell you, at least for the people that have been, because I mean, I'm thankful to say that I wasn't around at that time, but I can tell you that at least the people that I've talked to that have had that experience, that yes, I mean, for a lot of those people, again, put a little bit of humor into it. A lot of them say that back in the day, it was not how much moisture, but if you had less than a quarter of an inch or a half inch of standing water on the floor, you could get something to stick to it. And again, I'm not saying that the stuffs, and I'll talk about that a little bit, I'm not saying that the adhesives and things are better or worse. I mean, that's for people that are, have chemical degrees and polymer experience, but they're different. And so trying to continue to do, things like this, discussions like this, getting people aware of what the differences are. So to
sorry,
go ahead.
Just I say to general contractors that sort of push back and say, "What? We've never done moisture tests. We didn't do it 30 years ago. We don't need to do it now." The answer is, well, you didn't need to do it 30 years ago, maybe because you got a 2-for-1 adhesive and moisture barrier. Today, you don't get that.
Yeah, that's true. And like I say, there are definitely some differences in the products that we have out there.
Yeah.
But again, a little bit of humor into it. I mean, the 19 million a week is equivalent to a 40-foot semi dollar bill or $10 bills, top to bottom, side to side, front to back, that we're just dumping in the middle of the landfill. So anybody that's looking at trying to increase their bottom line or looking at P&L responsibilities on projects, or whether the entire project or the flooring side of it, definitely something to pay attention to. So just some quick pictures. I mean, this is definitely a residential environment, but it's something that I find to be interesting because this is a situation where this guy is a retired engineer, and this is his forever home that he had built. The contractor, both GC and flooring contractor, have walked away from him at this point because they think it's his fault. And so now it's his goal in life to try to prove them wrong so he can get his floor fixed. Microbial growth, reemulsification of adhesives and things along those lines, due to the alkaline nature of high levels of moisture in concrete. And then one of the industries that has been probably the slowest to adopt, in my opinion, is the coating manufacturers. Definitely something where they've used a lot of products that were very breathable over time. And as time has gone on, the products have become less and less breathable. So why are we having so many problems? I mean, part of it comes down to, and I don't have it on here, but I can tell you that part of it does come down to the fact that Chris and I were talking earlier, that at the end of the day, we don't do enough testing from a moisture standpoint. Again, some of it's realistic, some of it's not, but at the end of the day, we don't do enough of it. I still get a lot of phone calls, even after as many years as I've been doing it, of people that are wanting some type of information. And if you get down to it and ask them, they haven't done proper testing or any testing. So why are we having so many problems? Faster construction schedules. I'm sure that for any of you that are either in the GC community or the flooring installation community, construction schedules have not gotten any slower. You're not sitting around with your feet up on the desk eating bonbons. It's definitely, you got to keep things moving forward one way or another. Breathability in the flooring products. When you look at it, it ends up being, we used to do a lot of carpet, action back. We used to do a lot of stuff that was breathable, where you might not have as much problem depending on what you're going to put on top of that carpet. A lot of products that we're using now have, although it's environmentally friendly to do it, a lot of recycled content, different things like that. Again, I'm not saying the products are better or worse. It's just the fact that they are different. And we just need to make sure that we're being cognizant of that. The same thing with the adhesive side of it. Repurposing of structures, I think, in my opinion, is probably one of the bigger things. This is a situation where you have a 10,000 square foot shell that was built. Your tenant is going to come in and they want a 2,500 square foot build out for their offices. And early on in the process, it's decided that we're going to value engineer out the vapor retarder out of the other 7,500 square feet, because it's just going to be warehouse. And so you do the build out, everything's good. 10 years down the road, you end up with a situation where the tenant doesn't need the warehouse space, but needs to have additional office space. You bring in installers to do the flooring, same type of flooring, same adhesive, same everything. And people sit around and scratch their head and wonder why it is that we have a floor failure in the new edition and we didn't have it with the same stuff in the other existing build out. And a lot of that has to do with the fact that we don't have an intact vapor retarder. And I hate to say it, but I still see a lot of people that are still using or building without effective vapor retarders in general.
Yeah, 6 mil poly.
Yeah.
Oh my God.
Yeah, especially when you look at the amount of money difference it is for you to do, like, I'm not going to use any name brands, but to do, some different products that are out there that are, twice as thick. Yeah, it really, to me, it's a very short-sighted situation to look at sometimes.
Yeah, puncture resistant.
Yep.
I mean, all these things are critically important.
Absolutely.
Just had a vapor barrier underneath every slab on grade, and you turned the heat on and use fans to distribute the heat, you'd probably remove, I don't know, 80% of that failure rate that you were discussing at the beginning.
Well, and I think you'd have more realistic expectations of what the concrete will do.
Yeah.
I mean, we're just expecting. I have a slide that'll come up, but there's still a lot of people out there that think that curing and drying are the same thing. I hate to say it, but they do. And they think that concrete's just going to dry no matter what.
Day 30, I poured the slab. Get your installers out here.
Yeah, exactly. And I want you to do direct glue down, solid 3/4 inch, please. So yeah, I mean, it's interesting. So these are all the different concrete components, or the components that go into concrete. I guess the biggest thing I just bring up is if you look at the third largest as a percentage component in concrete is water. And so when we think about that and we look at the water to cement ratio that you have in concrete, you look at a couple things. A lot of the people out there that design the slabs will tell you that if we're going to put a low permeable membrane on top of the slab, that we really need to look at doing water to cement ratios, worst case scenario below 0.5. And obviously, as I show here in this slide, that 0.4 to 0.45. again, the more water you put into the mix ratio, the longer the drying time is going to be. And when you look at the overall quality of the slab, definitely decreases. I can tell you that although I don't get into it all the time, I've gotten into some specifications that I've looked at where, as I look at, the bottom one down there, that they're still in excess of 0.6 water to cement ratio. So definitely for people that are on the GC side or people that are on the flooring side and have the ability to get into the early side of construction, definitely something to keep in mind that you could help with.
I've heard before, part of the mix, part of the water component put into the cement truck is called free water. And that water is put into the truck just so you can get the cement out, or the concrete out at the other end on site. It's not actually used as part of the design, mix design. And so there's enough free water that it bothers the whole drying process. So what happens on site is the construction crew will go around puncturing the vapor barrier so that that free water can just bleed out into the ground. And there you're left with a building that's now going to have a problem with moisture for its lifespan.
Well, so since you brought that up, I'll share a quick story. So I do classes with NWFA. I've done them over the years, and one of the instructors for NWFA was having his forever home built. And because he had been involved in the educational process of understanding different vapor retarders and thicknesses and qualities and stuff like that, he actually paid additional money to get an upgraded vapor retarder underneath his slab in his forever home. He just happened to come home, and I mean, this is only within the last probably 5 years. He happened to come home when they were pouring concrete, and they had 5 trucks on the curb lined up. They had 3 that they had already dumped, and he just happened to be there watching as they were going around, as the concrete people were going around poking holes in that vapor retarder that he just paid extra money for.
There you go.
So yeah, he was able to get them to pull the whole thing up. But I mean, it happens. It still happens. So
it will happen.
Yep. So we're talking about the increased water to cement ratio. You'll notice through this presentation that it ends up being a situation where I show a lot of different visuals. But concrete. You look at the blue, it's the water. The gray is the cement particles combined. They're going to go through a hydration process, and you can see with this specific water to cement ratio, you have a fairly tight bonding of those molecules as the concrete starts to hydrate. Well, if we increase the amount of water, but we keep the cement the same, you're looking at the fact that when I talked about less quality, you really do have less quality because they don't have that structural integrity to be able to bind tightly. So the quality of the overall concrete is less, or the quality of the slab. So Chris, you were talking about water of convenience. So, this is a slide. If you look at it, and if we keep it at 0.5 water to cement ratio, we look at the fact that there's about 275 pounds of water per cubic yard. And if you look at a dump truck, roughly, 10-yard dump truck. So you're looking at about 2,750 pounds of water that's there if it's 0.5 water to cement ratio. Depending on where you look, about a 0.27 to 0.29 is what's necessary for the concrete to get hard. And so you're looking at almost half of it, even at 0.5 water to cement ratio, is going to be something that is water of convenience for placing and finishing. Unfortunately, for those of you who've been on job sites, you'll see a lot of times where those concrete finishers and the truck drivers will be talking to each other, and they'll be sitting there going through the process of adding more water to it that is trying to help it be even, lack of better technical term, sloppier. And so there's actually water that's being added to it that wasn't designed to be that way. So there's going to be more water for us to deal with. So for us to put a floor on top of it, as flooring professionals, you're looking at several pounds of water that has to evaporate from every square foot of the concrete. So when the concrete's poured, the whole point of it is that the slab wants to try to reach some kind of equilibrium with the indoor conditions. And when I say that, the pressure associated with having a high level of relative humidity in the concrete and the relative humidity and temperature in the environment really does dictate how quickly that moisture can come out of the slab and evaporate into the environment. So trying to get those conditions in the environment up to expected service conditions as quickly as possible is definitely very positive for the drying of the concrete. Couple of big terms that I hear used all the time still: curing versus drying. Again, when you look at curing is going to happen on a stopwatch. It is going to happen no matter what. You go dump the truckload of concrete into the middle of the ocean, it's still going to get hard. It's definitely not going to be a high quality product, and it's definitely not going to dry, but it's going to get hard. When you look at a general rule of thumb, once we conditions that are conducive for drying, so we have consistent temperatures, low to moderate relative humidity, lower the better. We have a situation where general rule of thumb is that it's going to take roughly 30 days for every 1 inch of slab thickness for that slab to get somewhere in that 85% relative humidity ballpark.
Or 1 millimeter a day.
Yep.
Yeah, of thickness.
So we look at drying again. I'm big on visuals. You look at drying, the white line that we have on the bottom there, or just above the bottom, is to represent a vapor retarder. You have the sub base below it. You have the slab that's been poured. As it starts to dry, or as it starts to have conditions that are conducive for drying, it will develop a gradient. So you're going to have less moisture on the top and more moisture on the bottom. That's great while we have it open to the environment, but once you actually put a low permeable membrane on top of it, then because of that pressure associated with having less moisture on the top and more moisture on the bottom, you're going to end up with a situation where between the vapor retarder and the low permeable membrane, the two of them are going to have to equalize between there. So you end up with a situation where, as I'll show you in another, if you take a relative humidity reading at the appropriate depth in the slab, representation of that at the surface is going to be fairly close because the moisture or the relative humidity is going to equalize. So everybody's seen a sponge. You get a sponge, it's completely wet, it's completely saturated 100% from top to bottom. You look at it, you put it up in the windowsill, it starts to dry out. The reason why it starts to dry out and curl like this is because you have an environment that is allowing the moisture to come out of the slab, and you end up with a situation where it starts to curl. And the reason why it starts to curl is because you have that differentiation between the top and the bottom of the in this case, the sponge. So the top has less moisture or a lower relative humidity than the bottom of the sponge, and so it starts to curl. Now, if you end up with a situation where you take, and we'll just say for visual representation, we put two of these together so you can see them better. You have them sitting on this very high-tech scientific experiment, sitting on top of a countertop. So you have, in effect, a low permeable membrane acting as your vapor retarder. And you come back through as they have dried and as they've started to dry out, and they have the moisture gradient has developed. We're going to come back in and we're going to put a low permeable membrane on top of them. And what you're going to see is, as that moisture starts to redistribute, you can visually see it redistribute, because now you're starting to see that the moisture from top to bottom has started to equalize, as I showed you earlier. So then the question always comes up: what happens if you're dealing with an old slab and you don't know if it has a vapor retarder, or what are the implications for that? Or what are the implications if we have a vapor retarder, or we have a slab that was built without a vapor retarder? Well, at the end of the day, we can do whatever kind of moisture testing you want to do on it, and it would be the epitome of a snapshot in time, because you're always going to have the potential for having some interaction with the moisture that's in the soil coming in contact with the slab, and causing some different issues with the flooring that's on top of it. So moisture testing, we have two different types of moisture testing. We have qualitative and quantitative. If we look at the qualitative side, you have the plastic sheet test, and I'm just putting ones up here that actually do have ASTM standards. The plastic sheet test, and we have non-destructive electronic meters. On the quantitative side, where it gives you an actual number, you have calcium chloride and in situ relative humidity testing. As I talked about, this right here is probably, unfortunately, still tends to be a very common testing method. And no, I know I'm having technical issues here with my presentation, but this is not one of them. As I said earlier, I still have a lot of people that either they're not getting the messages or they're not understanding the implications of not doing testing. And there's still a lot of people out there not doing proper testing. So we look at the plastic sheet test. When you look at it, it's the ASTM D4263. It's been around since '83, I believe. What you're looking at here is one test per 500 square feet, 18 by 18 inch, 4 mil poly. I always find it interesting that we're, specifying even the thickness of the poly to do that. 2-inch duct tape, and you leave that for a minimum of 16 hours. Now, part of the debate there is, are we actually looking at issues, or are we looking at moisture that's coming out through the concrete? Are we looking at dew point condensation issues on the surface based on the relative humidity and the temperature of the ambient environment, and the surface temperature of the concrete? So it really comes down to why it's a qualitative test, is because it really is just an indication that you should do if you do see things like this, which is the increased graying of the concrete in those areas, or condensation on the backside of the plastic, that you should be doing some additional quantitative testing.
That dark spot is indicating you've got anywhere up to 13 pounds of vapor emissions over the time period of the test. That's something I heard at a recent course. So it's what use is it?
Well, and that's it. I mean, you don't know. I had never heard somebody put an amount on it, because again, part of my debate with that is, I mean, that makes sense, but part of my debate with that is whether or not it's actually something that's happening because of the ambient environment, or if it's actually something that's happening because of moisture that's transferring, or the vapor emissions that are coming out of the slab.
I think, as you say, it's a great way to indicate whether you got moisture or not, and now get on with the more complicated, time-consuming ASTM testing, drill test or calcium chloride.
Exactly. So we look at the non-destructive electronic meters. Again, they have an ASTM standard, ASTM F2659. At this point, the test is not intended to give a quantitative test results. I know that there's much discussion about that, but at this point, it's not intended for that. The test is intended to identify the likely hotspots where the quantitative testing would be the most beneficial. I liken it to the fact of that, you could have a plastic sheet test in there that's going to give the indication. You're going to have to leave it on there longer to get any kind of indication if there is. With these meters like this, we can go around very quickly and be able to scan the entire area and find suspect areas that register the highest on whatever the scale is. Unfortunately, there really are a lot of variables in concrete, different admixtures, different aggregate sizes, different things like that make using these for an ultimate installation decision difficult. So we look at the first quantitative test. We look at the calcium chloride test, F1869. The most recent revision is the -16A. So it was revised in 2016, a couple of times actually. Qualitative evaluation that was started back in the 40s by Armstrong, and without any really written documentation, it transitioned into a quantitative test back in the 60s. Again, done correctly, it definitely does give you some information. The question becomes, how valid is the information based on how well the test has been done? Just a little bit of history as far as how it progressed. It started off as a dampness test, as I said. So you're looking at visual changes to the crystals. I got a good laugh, if you will, out of this one. The Rubber Manufacturers Association back in around 1963. I love the fact that it says no visible changes. So again, it's still something where you're looking at and making a subjective opinion based on any kind of visual change in the calcium chloride crystals.
Jason, sorry, I'm just interrupting quickly, just to let you know that we're at the 30-minute mark.
Yep. Perfect. And we said, okay, yeah, I'm not too far away. Since 1997, we really have learned that calcium chloride can be very unreliable if it's not done properly. And then when you look at it, being able to look at the results and to evaluate them from the longevity of a flooring installation. You can look at the different ambient temperature and relative humidity issues in the environment that can have changes to it. Water to cement ratio. And then for a lot of people, it's still interesting because the use of lightweight aggregate is something where you're not supposed to be using any kind of calcium chloride testing on. So a question I get a lot is where are we actually getting, what results are we getting when we do a calcium chloride test? So what this graph is showing very quickly is the fact that if you look at the horizontal, is the percentage of how far or what the actual result from the calcium chloride test is. If you look at the vertical, it is the depth or how far we are into the slab. Basically, when you look at a calcium chloride test, even done correctly, you're only looking at best case scenario about through the top 3/4 of an inch of the slab. And we know that there's a lot more going on in there. Now, does that mean that it couldn't give you some kind of information that might be valid? It just depends on whether or not it ends up being something where you're going to use something like that exclusively, or if there's going to be multiple tests that you need to conduct. Up to you, but that's what the information is. We look at the calcium chloride testing. Again, these are some of the critical things. Ambient conditions. If you look at it, 3 tests for the first 1,000 square feet, 1 test for each additional 1,000 square feet after that. If you look at that, it really comes down to the fact that we're trying to get it to a point where it is looking at truckload to truckload, any variations from test to test, because 1,000 square, a truckload of concrete, 4-inch slab is about a truckload of concrete is about 1,000 square feet. So we're trying to look at any different representations of various truckloads. Nice thing that they changed back in 2016 was the way you do the testing. You really do need to grind to a specific CSP profile. Before that, it really wasn't. It was left up to vagueness. If you have a situation, another thing that changed, if you have a situation where the slab's over 30 days old, never been installed upon, you can grind to the CSP1, CSP2 and set the test immediately. But if it has been installed upon, you need to grind it to that CSP, let it breathe for 24 hours, and then come back and install the test so you have an additional trip to come back.
Jason, just expand on CSP for those that haven't heard that term.
No worries. Concrete surface profile. So it's a very specific, you can actually go to, there's various pictures for it, but you can go to ICRI, so International Concrete Repair Institute.org. And they have some, well, a couple things. If it was critical, they actually make molds, a keychain or key ring mold of these CSP profiles that you can look at so that you can compare them to what your profile is. The other side of it, they have some very good pictures. So it's just allowing you to understand how much you should grind, because if you grind too much, it's going to give you false information. If you don't grind enough, it's going to give you false information. So now we jump into relative humidity testing. If we look at the ASTM standard for this, it's 2170. The last revision was in 2019. I've been talking about this since 2005, and it was interesting because a lot of times the people thought it was a great concept, but they didn't want to jump into something that was new. And really, when you look at it throughout the world, relative humidity testing in various parameters really is not something that's new. It's been going on for quite some time. Interesting thing is we've had ASTM as far as an ASTM standard on the book since 2002, but realistically, you didn't see it really start catching on until probably 2010, 2009. So if we're going to look at one snapshot of the relative humidity testing and the parameters of relative humidity testing, this is it right here. Basically, if you look at the red line is when the concrete's poured, it's 100% relative humidity from top to bottom. So I've talked about moisture gradients numerous times. If you look at the moisture gradient, it starts to develop. That's what the yellow line is. You have more moisture on the, or less moisture on the top, more moisture on the bottom. But what this scientist wanted to find out was he wanted to find out, is there a depth within the concrete slab that I could measure that would allow me to see what the relative humidity is in that concrete right now? But it would also allow me to be able to predict what's going to happen on the surface once I put a low permeable membrane on top of it. And that's where you look at that green line and where it intersects with that yellow line. So that's where we come up with, as I'll show you in a second, that's where we come up with when you're doing relative humidity testing in the concrete. That's why when it's a slab drying from one side, you go to a 40% depth. So to give a little bit of perspective on it, you look at 74% on the top, 99% on the bottom. That's why it's open to the world. You take a reading at the 40% depth, you get 85%. Once you encapsulate it based on the equilibration that we talked about, you start looking at the dynamics of what happens where you have 85% relative humidity in that 40% depth. Really hasn't changed, but the areas around it have equalized. So if we look at the overall parameters of ASTM testing, you look at the concrete slab, and the conditions of the occupied space need to be at service conditions for at least 48 hours before. Same situation as far as 3 tests for the first 1,000 square feet, 1 test for each additional 1,000 square feet after that. The depth of the hole can be different. You can either go to 20% or 40% of the entire slab thickness, depending on whether or not the slab is drying from one side. So if you have a slab that's drying from one side, so a slab on grade, below grade, or a slab in pan decking, you're going to go to 40% of the entire thickness. If you have a slab that is structural in nature, where it's elevated and you know, for all intents and purposes, can stand below and look up and it's concrete, or stand on top of it and look down, it's concrete, you only drill to 20% because that drying or that gradient is different. Depending on the type of product you're using or what product you're using, you have sensor or sensor and sleeve combination that's installed. You cap it off, you leave it for 24 hours, and you come back and get a reading. So the debate in 6 minutes that we'll have a talk about is the equipment options that we have out there. We have single usage sensors for doing the in situ testing, and we have reusable sensors. If you look at the single usage sensors, they're the easiest to comply with ASTM protocol because of some of the things that are below here. You're only using them in one hole. There's a NIST traceable certificate of calibration, which is required as far as proving that they met the ASTM standard when they were installed. Nice thing about them is you put them in, use them in one hole, and they can be read multiple times over time. Once you've let them in the hole for 24 hours, there's no need to wait again for more time to take a reading. So you can come back at any point and take a reading. And then really, when you look at it, part of the issue with, and again, it's, you know, it just really depends on what works for you. But in doing a single usage product, you don't have to go through and worry about the periodic calibration verifications that are required by the ASTM standard. We look at reusables. So theoretically, they're reusable for 12 months. Now, sometimes when I say theoretical, you never know what's going to happen to them when they're taken in and out of holes. You know, there could be some issues. On the other side of it, I say theoretical because there are going to be some companies where you can send them back based on the standard. You have to send the product back to the manufacturer once a year to have them certify or recalibrate, as it says. Unfortunately, most of the products that are out there on the market are digital in nature, so it's not going to be something where we could recalibrate them if they are out. There are some companies you can send them back and they will verify the calibration and recertify them for a cost. At the end of the day, most of the time I'll tell people just to be realistic that, you know, just plan on repurchasing sensors every 12 months. Requires calibration verifications 30 days prior to each usage. So you have to, that's an onus that's put on the user. When you use them, sensors, if you don't leave them in the hole for the entire 24 hours of the test, you're going to have to put the sensor in there and allow it to acclimate, which is going to be another thing that's going to take time. Again, for some people, like, you know, people that do nothing but concrete moisture testing, it tends to be a very, very, very viable type of product to use. And then we look at the other side of things. When we look at the different types of, you're also going to have the data gathering technology that we have out there. So, you know, there's going to be companies out there that have Bluetooth functionality so that it helps to gather the data better. It helps with the data integrity side of things. So it's not just writing things down. It's a data transfer that the user really is not having any input on. You can look at the fact that there are some in situ data logging and storage, where the storage for the information and readings is being left in the sensors, or it's being left in the data logger. Allows for more data integrity. Applications and software for recording and reporting. A lot more professional output of data that you have, so that when you are presenting it, whether it's to a GC or GC to the end user, it ends up being something where it's definitely a much more professional and easier to present report. And then there are going to be, and there are, you know, definitely some out there, but there's going to be some more that have remote data acquisition. So it ends up being something where, for people that are doing the testing, they don't necessarily even have to go back to the job site. Once they've installed stuff, they can just sit in their office and monitor it via their laptop.
I think an important note there is this data gathering technology is not particularly expensive. We've had numerous conversations when we have our quality assurance program on the project, where we advise the general contractor, because this is the general contractor's responsibility to take these tests or pay for a third party to come in and do them, advise them that data gathering technology is going to put them in control of their site. You can't manage what you can't monitor. And you know, we were on one project in a prairies, it was in Manitoba, very cold, right in the heart of winter. And, you know, typically I think there they throw their hands up and say, well, you know, it's Manitoba. We're not going to worry about RH and temperature. It's just going to be freezing cold and very dry. But we got data loggers on site, about 100,000 square feet, 10 or so units. And I kid you not, the site super at a meeting we had said, you know, I love this technology. I know when a delivery has happened on the east wing of my building and the guys have left the door open, because the next morning my RH and my temperature readings and graph that I download is dropped right off. And so they were totally into it and had no idea that this technology existed. So push that as much as you can. I'm going to go on a little bit and say, you know, we're a floor covering association. And a lot of people say, why are you having moisture testing information delivered to floor covers, when at the same time you say that floor covers are not responsible for taking ASTM testing, certainly calcium chloride and relative humidity tests. And I agree with them. Yeah, it's not. Our standard says that the general contractor must provide and pay for third-party testing. ASTM standards don't say who does these tests. Manufacturers' installation guidelines don't say who does these tests on site, but the NFCA floor covering reference manual absolutely does. It delivers the responsibility to where it belongs. And Jason, I'm sure you've heard of, you know, 50,000 square feet, 52 calcium chloride tests and plastic boxes, little tests spread out across a busy construction site. And the electrician and the drywaller just kicking those boxes off their station and spoiling the tests. If you're a flooring contractor caught up trying to get meaningful test results, you're going to go broke trying to do it. Or, you know, which is bad news for the owner, cut corners. the general contractor is the only one that can control the site, and the trades walking through those testing fields. So that's why we, the trade standard is to have the third party come in and do it. It's complicated. We just had testing in a testing course, certification course in Edmonton, where 11 people went through the ICRI, International Concrete Repair Institute's training schedule, and came out the other side certified. And we learned, I was there through the training, and you learn that, wow, if you're just a floor guy trying to do these tests, you're not going to get it right. You have to be trained to do it. And that's my rant this morning.
Yeah, and I mean, and again, I agree wholeheartedly with what you're saying. And obviously you guys have things set up a little bit differently than down here, if you will. My problem with that down here is the fact that we have a lot of people that have decided that because moisture testing is such a prevalent thing that's out there, that anybody can do it. And I've had some very, very, very seemingly intelligent professions that have taken it upon themselves to do testing. And I can tell you that the flooring contractors did a better job than they did. I'll just leave it at that. So, my thing down here, and I'm not, again, you guys, Chris, you've done a great job, and the association up there, you guys have done a great job pushing that third party testing. And I was involved in the, if you look at the WFCA white paper down here for independent third party, we revamped it from FCICA was one of the integral parties to revamp it. Pushing third party testing. I always tell the flooring installers down here that, just make sure you are knowledgeable enough that if for some reason somebody does present you with a result or something, that you can at least throw up a red flag and understand what you're looking at.
Why it's an interesting point you make. Why the floor covering contractor does the best job is because they are responsible once they start installing. Yep. Especially if they've taken those tests. If they're wrong, they're owning it if that floor blows off the concrete.
Yep.
Yeah, we've even had engineering firms on some of the projects we've worked on that have come and done the tests wrong. In one case, we had probably 50 or so calcium chloride tests, no grinding. That 20 by 20 area to be grinded before placement of the test, not done. So all the tests had to be redone. So the flooring contractor that takes on the responsibility of taking moisture tests, it's a high risk. Our standards in the trade say that, as I've mentioned, third-party testing agencies should be brought in, paid for by the general contractor. Once those tests are done, the flooring contractor, before they proceed, must verify that the tests, A, have been done, and B, they pass. So the flooring contractor should be screaming for the results. Give me the results. I want to check that all those calcium chloride tests came in at 3 pounds of vapor emissions over a 24-hour period for 1,000 feet. If they don't do that, again, maybe those tests were taken wrong. Maybe they're all 11 pounds of vapor emissions. And by installing, you're saying, we're ready to go. We're owning this situation. Really important.
No, and understanding really as an installer, understanding what information should be being given to you. So, if you get a report that says 3 pounds, and okay, I want to see pictures of XYZ. I want to see that it was prepped. Those are things that it should be part of a report that's given. I mean, I give you the worst one I think I probably have ever seen is that flooring contractor got results. They were different from the GC didn't like them. They were different from a third party that he brought in later. The third party, when I asked for the report so I could see it, because of course I was being asked to look at it, it was a very official document, 1 page. It had probe 1, probe 2, probe 3, and probe 4, and it had a relative humidity reading. That was it. There was no ambient conditions. There was no how deep. There was no how thick is the slab. There was none of that information that was there. And so had that flooring contractor been, just said, okay, hey, that's great. Because what the guy had used was he had actually used a device that really is intended to go on your back porch. It just happened to have a corded probe to it. It just happened to be 3/4 of an inch diameter, but there was no sleeve, there was no nothing. So basically he was sticking it down in the concrete, but he was just getting ambient readings.
Corner cutting.
Yeah, exactly.
We were on a healthcare project, a lot of square footage, and as the inspection agency, we were saying you must provide the results. Finally, the results were given up, and I think it was like one test every 10,000 square feet was done instead of one test every 1,000. Fail. Jason, we got some questions coming out at the bottom. I'm not sure if you can see the chat box. Maybe you want to click on that.
Yep. Nope, I got one. So methodology for probes is based on a monolithic slab. What testing is appropriate with toppings such as dry pack or cementitious leveling toppings on top of a slab? I mean, that's a great question. That's a great point. A lot of times, and I can't say it for every manufacturer because I can't, obviously I don't speak for everybody for manufacturers, but when I look at, I should be testing that concrete slab before I do any kind of toppings on top of it anyway, because usually the appropriate steps, if you will, are going to be a slab and a mitigation product if it ends up being something where the slab is too hot, and then the leveling product on top of that. As far as testing, I'll get phone calls where somebody will say, I'm on a job, I need to go through and test, like you're saying, it's a slab with topping or leveling products on top of it. I need to moisture test. It's like, did you moisture test prior? No.
Because some topping material have limitations.
Yeah, well, and that's it. And sometimes, yes, you could go through and do it. Depending on the manufacturer. And I know that there are some out there that I've been surprised about, but they do have them.
So let's say that, it's an old slab and it's got 3/4 of an inch of topping on it that's been there for 20 years.
And that's going to be the debate with the testing. I'll have some people, there's not going to be a black and white answer. I mean, there's not going to be a black and white answer. If you're dealing with an old one, you're probably going to find some people that may go through and do some kind of evaluation that's kind of a hybrid evaluation. They may go through and test it as one entire thickness. So if you have, say a 5-inch slab and a 1/2 inch of leveler on it, they may do if they're going to drill, they may do that. You could find some people that are going to go through and they might use a surface meter to look at some indications to be able to get some idea on it and then do some other type of topping. But I mean, or not some other type of topping, but do some other type of a quantitative test.
This topic came up in the certification class we were taking in Edmonton, and Graham Rosen, you're on the call. Yeah, can you hear?
Yes, I am.
Didn't you raise this topic and ask the instructor what he would do, what we should do as moisture testing agencies?
Yeah, I think there was the topic I brought up was just the arbitrary nominal slab thickness. It's decided upon that it's 4 inches thick, but then in reality it goes from 2.5 to 6, and that would throw off the calculation. So it's slightly off topic. Sorry, Chris.
Okay. Well, I thought the message I got was that if you have a 3/4 topping, 3/4 of an inch topping on top of a 6-inch elevated slab, you're going to measure 40%. If it's elevated, it's going to be 20% down from the surface of the topping. That was my understanding. Now, if that is wrong, then now's the time to We have to get in touch with ICRI and check that. But that's what I got out of the certification course. So you include the topping.
Yeah, and I mean, here's, and again, you know, those people are very, 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 very smart, and they've, you know, especially depending on who did it. I mean, if Peter was up there doing it,
it was Adam who sits on the ASTM.
Yeah, and Adam's extremely knowledgeable. You know, the debate could be made that, you know, if you're talking about an elevated structural slab, we're not talking about a cast or a precast. You know, part of the debate with precast is technically when that stuff is, you know, when it's manufactured to an extremely dry state. There's a lot of those precasts that are hollow. And so if you were to drill through and you got into one of those, are you really looking at anything that's going to be of any value when it comes to, you know, testing overall? The thickness that you put on top, again, if you were sitting there dealing with the situation where you had one continuous pore structure, then yes, you could do two different lifts and you would have an overall thickness that you could look at. Like you're saying, if it's 6.5 inches, it'd be, you know, 6.5 inches, and you go, you know, 20% of that. You know, some people may debate that. I don't know that it's that. I'll put it this way, Chris, I have never had somebody tell me that it was that cut and dry.
Right. Have you ever had someone tell you that you have to chisel off the 1/2 inch of topping, get down to the base slab, and then use your 20% depth? I haven't heard of that.
No, and I haven't heard that. You know, part of my thing on a situation like that, and I'm going to get back. Let me get back, so I'm getting off topic. For this one gentleman's question, bear with me because I just had another one. New slab looks like a foot thick and 3 inches of dry pack. So yeah. You know, and I'm sorry, I'm not laughing at it. I'm just, we've thrown now a whole combination of stuff. So real quick, there are some different conversations, some different debates that are going on out there in relationship to excessively thick slabs. Looking at the fact of whether or not it is, you know, what that number is, you know, is it an 8-inch thick is quote unquote excessively thick, or is it a foot that's excessively thick? I say that because at some point is a point of diminishing return when it comes to that moisture gradient that I talked about in the slab. The thicker the slab, I mean, you could go to say 40% or 60%, and depending on how thick the slab is, you might end up with you know, relative humidity results that are fairly consistent, because it's going to be something where you're not going to have as much of a pressure differential because there's such mass in that concrete. So when I say that foot thick with, and I'm not going to, it gets harder as you get thicker on some of these slabs to use the products that are currently on the market to test relative humidity. 12 is usually going to be about the thickest that you could go. If you were looking at a new slab with a foot thick and 3 inches of dry pack, so you're looking at, you know, let's say 15 inches thick, some people in that situation are going to put the two of them together, especially if it's a new slab and the dry pack, you know, obviously is fairly new, and you're going to end up with what Chris said. You're going to have some people that they may negate the dry pack. They not take it off, but they will drill through the dry pack, and then they will start testing that new slab below just to see what's there as far as going 40% of that. So, you know, I wish I could sit here and say there's an absolute on it, but there isn't an absolute because of the variables.
I guess one way of looking at it is test in a way that is most likely going to give you the wetter result. You're trying to test the worst case scenario. An example would be, if trenches have just been dug for ducting and whatnot, guess what? After the trenches are filled in, that's what you test. So if the topping is a typical Ardex or a Mapei or custom building products, Leadcrete, all those companies, those products are manufactured to dry very quickly.
Correct.
So if you include that in your 20% or your 40%, you're probably going to improve your chances of passing. So at that point, it would be like, okay, if you've forgotten to do the test, because you always test the base slab before you put anything on top of it, then now it's time to dig a hole.
Sorry, Chris, I'm just going to interrupt because we're at 11 o'clock and we still have one more question from Daniel.
Okay. Yeah, so maybe it is you remove that topping and test the base slab to test for your worst case scenario. Let's move on to the next question.
Yeah, let me just make one comment, and I'll make it quick. So, and again, in that situation, Chris, it wouldn't be the fact of having to, if you were going to do relative humidity testing, it's not the fact of having to take any of the topping off. You just need to make sure that you're drilling through it and you're not calculating your depth until you get through that topping.
Right. Very good point. Thank you.
So, yep. So Dan, how can we apply an effective moisture testing procedure policy in residential applications or renovations where a typical contract from start to finish can vary from 1 to 5 days?
Oh my God, that's a tough one as well.
Well, it is. I mean, and I'm going to say that's probably, one of those areas where if I had to say anything, the residential market is definitely something where it's hard to come up with something that's viable. Here's what I can say in some of the things that I have found. And I think that I'm not sure if it was during the discussion and whether Daniel heard it or not, but I've had numerous retailers that I have consulted with. And again, I'm not saying that from a, hey, I'm a high powered consultant type of guy, but they called me and asked for some input. And one of the things that has been fairly effective comes down to, and again, it comes down to the process before we do some of these residential settings. And again, it really just depends on what your business model is and how you go about it. But we have a situation where you do a bid, you go out there, you pull the corner of the carpet back, or you do whatever you're going to do. And sometimes they'll take, a surface meter and put it on there just to get some kind of indication. But you end up with a situation where you could still have, because that's not going to be the best, quantitative result that you could get. It's going to be something where you're still going to have to sit there and deal with, what are the implications, or you're going to have to cover yourself. So you're going to do a better adhesive, which that could be a whole nother debate that we could have about that stuff. But
I guess having been that contractor doing multiple residential contracts, and yeah, the 100 square feet, what are you going to go do 3 calcium chloride tests in 100 square feet? I don't think so. You didn't hear that from me, because that's but it's not easy to say, but it all boils down to the manufacturer's installation guidelines. If you've got an LVT product that says you're okay to proceed with an indicator test, and they quote a scale that represents, maybe it represents Wagner, maybe another manufacturer of testing equipment, do the manufacturer's follow the manufacturer's instructions, and photograph what you're doing. Because if you can prove that as a professional you're on site testing that 100 square feet in accordance with the manufacturer's instructions, later on, after the 100 square feet blows off the floor, you're actually covered. It's very difficult to give an installer a bad time that can actually prove they did their job according to their recognized trade scope of work. Doesn't make it easy, but that is at least a guide.
Okay, well, thanks for saying that, Chris, because I missed the second part of his example. So, but again, like even based, I mean, and you're right, most manufacturers do instruct that. So I guess where I was going with from your standpoint is that when you're sitting there and you're in that bid process, it ends up being a situation where you really do need to be putting the moisture testing time in there. So whether it's a situation where you have to go in a day early to do the testing so that you can come back in the next day. And I realize it's only I realize it's only 1 to 2 days, or have a situation where if your business model is set up appropriately, that you're upselling on that moisture testing side of stuff so that you're breaking that in as a line item ad on your bids. You're going to find out that I think you could probably do it correctly and probably be able to make a little bit more money on it.
Yeah,
That's what I found.
there is a right way and a wrong way. It doesn't
Yeah.
make the right way easy.
But I will say, back to the original, back to Daniel's point, if there is an area, in my opinion, that's really, the residential business model is very difficult for moisture testing.
Yeah.
There's no ifs, ands, or buts about it.
Yeah, no, our standards sort of don't differentiate between residential or commercial, but they're heavily weighted towards the commercial market because, you know, 50,000 square feet is a lot more problematic than maybe 100 square feet. You pick your battles. Again, you didn't hear it from me, but when I was contracting, we would pick the problem jobs. Every slab on grade got tested. You know, if a manufacturer calls for ASTM 1869 and we didn't want to do that, we would go looking for a manufacturer that just had indicator tests required or mentioned nothing about it. Yep. So, you know, you can look at it that way. Because doing everything right is not realistic. You don't have the manpower, so you pick your battles.
Well, and again, if we were going to sit here with a lot of this stuff, if we were to sit here and look at like existing renovation work, if we were to sit there and look at that, and most, you know, and I said this earlier in the presentation, if you don't have an intact vapor retarder, the moisture testing you're doing, that is the epitome of snapshot in time. So then the question becomes, well, how do I know if I have an intact vapor retarder? Well, I mean, again, it comes down to that if you were looking at renovation stuff, if we were going to do everything absolutely unequivocally with no, you know, no thought for cost or anything like that, you'd be doing core samples. You'd be doing core samples to find out if there's an intact vapor retarder. But, you know, the reality is that that's probably not ever going to happen. So we have to try to make the best of of not the best situation and try to change it slowly but surely.
Yeah, that's just this is a good question period. But I just want to talk about cost of ASTM testing. There's a lot of misunderstanding out there, and it drives some pretty wild actions. You know, one situation I ran into, again, quality assurance was a third-party inspection service was on the job, so this became very transparent and known to the whole construction team. But the architect phoned me and said, "Why are you making our contractor take 82 drill tests on a 40-year-old slab?" He said, "I got two questions for you, that one. And the other is, why are those tests costing almost $200,000? And I said, okay, well, that's very interesting. One, we demand that those tests are, or we echo that those tests are required because that's what the manufacturer wants, and you want the warranty, right?" And he said, yeah, we want the warranty. And also you can't put your mother's life on it that all those slabs, elevated or slab on grade, are dry, right? Yes, he conceded. Yeah, you got me there. But what about the price? That's ridiculous. And I said, yeah, no doubt. It sounds like someone's added a zero by mistake. Interesting, he said. So what should they cost? 82 tests. And I said, well, I don't know, around, you know, you divide it by $200 a test or whatever, about $18,000. Interesting. So he said, I'm going to get back to you. And he went away for 48 hours, came back and said, oh my God, we found the general contractor pricing it through the roof so that it would go away. That was the long and short of that story.
That's impressive. I mean, I would probably quit my job and do moisture testing at that much.
No doubt. But, you know, we've got projects that are, I mean, if it's 100,000 square feet, you've got to do 100 tests at $150 to $200 a pop. Do the math. This is why we brought the certification test to Edmonton, because we couldn't find a testing agency in Alberta. I knew of one guy, so we needed more out there. So we did that. We're taking the same course to Ontario as soon as we can organize it. But you know, it's not about there's good money in it, but warranties cost money, and owners want the warranty. No owner has ever said to me, "Yeah, no, we don't want the warranty. Just carry on." So
No,
it's a
I want to,
fun topic.
and I'll say, because you brought something up I wanted to go back to too, since it looks like that we've, unless some more come in, but you brought up a point about the data loggers for ambient conditions.
Great.
Yeah, and I mean, you know, the one thing, and again, I'm not going to get into, because this is not company specific, but we need to keep in mind too that there are going to be products out there, and there probably are other ones, but there are products out there that, you know, your GC in that specific situation, that he could actually have the ambient sensors set up with push notifications, that he could be sitting at home and he would get a push notification to his cell phone that would say, hey, you got an issue in this area of the building, or you have, you know, it's outside of whatever the parameters are for, you know, what you're installing. And to one up that, there will be a specific one that will come out that will also have the ability to do the same thing with relative humidity testing in the concrete. So it ends up being something where, again, keep your eyes open for any of you out there that are into the technology side of things, and trying to save time and do, you know, again, a better job. There's a lot of times it's surprising, because the ambient sensors like that, they're not new. They've been around for a while. They just haven't, in certain markets, they just haven't become prevalent, as far as, you know, like with flooring. So, you know, just something to keep in mind, because technology is always evolving, and there's definitely, you know, some very positive things that continue to happen.
Exactly. Jason, let's think about wrapping things up. We've taken enough of your precious time. Are there any other questions from the remaining audience? If not, I think that's a lot of information in a short space of time, and